Hey everybody. So this is the teaching video for lesson 6.2.2 and we're continuing our introduction to statistics here. And this is going to be very similar to the work that we've been doing already in statistics, and that is that I don't expect that you're going to learn any formulas or anything like that. That is something you'll do later in a statistics course. Really, the major goal here is just for you to know that these things exist, and then how to use the Desmos graphing calculator just a little bit to determine some things. All right, so the goal for today is to learn about the correlation coefficient. And what I'm going to do is I'm going to show you a little bit about the correlation coefficient, and then we'll come back and read about it and then take a look at a variety of graphs. Okay, so I'm going to go over to the graphing calculator here. On this particular graph, I have already basically put some points in, and you can see there's a fairly strong linear correlation here. It's a linear pattern. Remember when we were describing associations before, we would describe them as linear or nonlinear, so this is linear. We'd describe them as positive or negative, so this is positive, and then we would use our own judgment to say whether we thought they were strong or weak. Right? I would say this one is strong. And then I've already plotted the residuals here, so you can see, yeah, this is strong. This is the least squares regression line. That is a great line, and we know from the work we've done that is the best fit, so the line of best fit. All right, but for today, what we're going to do is talk about these pieces here. We already know this is the slope and the y-intercept for the line. We already know that this is the plot of the residuals, but these two numbers we haven't discussed yet. So right here, the R is the correlation coefficient, right? So the R squared we'll come to later, but for now I just want you to focus on this one. So the correlation coefficient between the x and y variables on this is 0.9922. Right, now what I'd like us to do is go back. Let's take a look here, like what does the correlation coefficient mean anyway? Like why is that important? All right, so here's why. First of all, just a quick review of this. All right, you may recall that to find the equation of the least squares regression line, your calculator minimized the sum of the squares of the residuals. The smaller the sum of the squares, the closer the data was to the line of best fit. Right, so I don't know if you remember, but there was a line, there were little squares there, and as we moved the line around, as it got closer to the clear line of best fit, the squares got smaller. All right, continuing on here. However, the magnitude of the sum of squares depends on the units of the variables being plotted. Therefore, the sum of squares cannot be compared between different scatter plots. Okay, that's the key right there. We can't use the LSRL to compare between two different scatter plots. We can find the best line of fit for one scatter plot or one set of data, but we can't compare the strength of that line with another line, right? So that is where this comes in, the correlation coefficient. We now can actually give a number to how strong an association is. Right? And because we can do that, we can compare quite precisely the strengths of two different scatter plots. Right? This becomes very important for statisticians. So the correlation coefficient R is a measure of how much or how little data is scattered around the LSRL. That is, if you have already plotted the residuals and decided that a linear model is a good fit, correlation coefficient, R, is a measure of the strength of a linear association. The correlation coefficient does not have units, so it's useful no matter what the units of the variables are. Okay, so the point here is we can now put a number to how strong an association is. We don't have to just make our own guess about whether it is weak, moderate, or strong. We can put a number to it. Okay, so we took a look at this one. Right, I want to take a look at this one next. All right, and again, I've already graphed everything out here, but I want you to take a look at the data first of all. Okay, so I have put this in the table over here. You can see this is the residual plot in blue. But if you look at the line, so let's look at this as well, you can see that this is actually a negative association. All right, well, let's see how that affects the correlation coefficient. All right, so you can see right here, the correlation coefficient is negative 0.9964. Remember on this line we did before, it was a positive correlation. So right there, the correlation coefficient is quite useful because it tells you whether it is a positive or negative association. All right, so there's that. Also keep in mind, like if we're thinking absolute values, right, this is pretty close to what number? Yes, it's pretty close to 1. If you look at this, also a strong correlation, pretty close to 1. All right, so hopefully this is making some sense. Let's look at another one where we can move points around. I have actually kind of created this situation where we've got points all over the place, right? And so I want you to notice here, look at the correlation coefficient, right? You can see actually that it's a lower number than the ones we've looked at before. And I have already plotted the residuals here. So that's pretty far away. Like this is not the greatest line of fit here at all. I mean, it's not a strong correlation, I guess is what we need to say. And this number would tell me that. I'm just going to say this about R squared. I'm not really going to refer to this much anymore. We're going to do one more lesson from this unit, and it will be on this. But this is 36%. So I would say it like this. The variability here between these basically is 36% due to the data that is reported as X and Y values. Okay, now that was a strange way to say that. I'm going to be talking more about that later. I think that the important thing for you to remember is think about this as a percent, right? And the fact that this is a bit lower percent means that's not a very strong fit. All right, so watch what happens. I'm going to start pulling lines, points closer to the line. Watch what's happening to the correlation coefficient as I do that. All right, so you can see, well, this point's not that great, but there we go. All right, so I'm pulling things closer and closer to the line. All right, so you can see what's happening here. All right, let's see. All right. And then, see if I can get these all on here. All right, you can see what's happening. All right, I'm trying to pull things onto the line the best I can here. All right, can you see what's happening here? All right, the closer I get to getting everything on the same line, what happens to the correlation coefficient? All right, it's getting higher and higher and higher. Okay, now let's do this. All right, I'm actually going to change my table here. I'm going to pause the video while I change it. All right, so you'll see, I'll pause and change it so you'll see what I decide to do. Okay, guys, so I changed the table. All right, and I have made it so that all of my points are going to be exactly on this line, right? And I want you to watch what happens when I put in the least squares regression line. All right, you can see what R equals here. All right, so if everything is exactly on the line, then this would be its value. The correlation coefficient would be 1. All right, well, what if I just came through and made all of these negative? So I think I can do that fairly quickly. Whoops, -4, -8. So watch what happens once I'm done with this to the correlation coefficient, although it might be interesting for you to watch what's happening right now to the correlation coefficient. All right, so right here, you can see that, make this fit better, you can see that the correlation coefficient has now become -1. All All right, so again, if the points are directly on the line, it's going to give you a correlation coefficient of either 1 or -1, depending on whether it's positive or negative. All right, so I'm hoping this makes sense. Your correlation coefficient is always going to be between and including 1 and -1. All right, let's take a look at just a couple of other things. And really, this is all we're going to do today is just kind of observe what happens to the graph and what's the correlation coefficient. Okay, so right here, I started with a table, and you can see the equation for this line is just y equals 5. And the way I always say that is y always equals 5. It really doesn't matter what the x is. So I would say then there's no real relationship between the x and the y. It doesn't matter. X can be anything. So what happens when we have a horizontal line is the correlation coefficient becomes 0. So RMSE is a different term in statistics, which I'm not going to get into, but just consider now that the correlation coefficient here is 0. So 0 slope means 0 correlation. It basically means it doesn't matter what x is. All right, here's the other last one I'm going to show you. All right, this is, of course, a vertical line. So in my table, I just put in all 3's for my x's, so it would just be x equals 3. Again, there's no correlation between the x and y, because in this case, it doesn't matter what y is. Right? But in this case, they call the correlation coefficient undefined. And again, that's because it's got an undefined slope. And again, I kind of think about it as the relationship is just not clear. Right? It's kind of similar to a horizontal line in that there's no relationship between the x and y. So basically the correlation coefficient is meaningless in both cases. But when there is a horizontal line, we do just say there's a 0 correlation. But if there's a vertical line, we say it's an undefined correlation. There are reasons for that have to do with the mathematics, but I'm not going to get into that right now. This, by the way, is an error, but that is because it's trying to put in a straight line, and we have confused it. All right? Okay, I have a few guided notes I want you to fill out just to show me you watch this, and you'll just hand that in on Google Classroom. And the important thing is, have a great weekend.